are going to be solving problem 51 from the June 2012 Regents. This problem involves springs and potential elastic energy. To start off, we can start off by reading the problem. This problem is actually a two-part problem. Well, it says it's 3 questions, but really part 2, which is question 52 and 53 are really one part together. So it will be 2 separate videos, one for question 51 and another one for question 52 and 53. The problem says a student produced various elongations of a spring by applying a series of forces to the spring. The graph below represents the relationship between the applied force and the elongation of the spring. So if we look at the graph, first let's read what 51 is asking us. It is asking for the spring constant. So just from that, we can go to our Gibbons part of our gear method and put K, which is equal to the spring constant. If you check your reference table, question mark, since it is what we are trying to find. Next, there are actually 2 ways of doing this problem. One, you can just get the answer straight from the graph. Well, for both methods you still have to use the graph, but to get really the information, we know that K, one of the formulas, since they are in the graph, they give you information on force in elongation, which is equal to X. So just from that, you know that the only formula that uses force, elongation, or X, and the spring constant is the formula for force, which is equal to Kx. So you can just know, then you can just record the information in the Gibbons part. So force S, or force of a spring, I guess, is equal to 4. I'm gonna take 4 newtons and then 0.2 meters, since that's where it like matches up around there. That's like where it's equivalent. So 4N, and X is equal to 0.2 meters. Now that we have this, we know that the formula that we are going to be using is force spring Kx. Let me put this, there we go. Next. So now we can move on to actually solving the problem. We can just start by plugging in all of the values that we have. So that's going to be 4, let's put this in parentheses, 4n is equal to K, since that is the value that we are trying to find, 0.2 meters, and all we have to do is really isolate the K by itself, and to do that all we have to do is divide by 0.2 to both sides, which will give us 0.2 meters, and let me actually do there, 0.2 meters, 0.2 meters, and that's going to give you K equals 20 Newton meters. And we can go ahead and actually put that on the results part of our Gibbons method. So K, or the spring constant, is equal to 20 Newton meter.